Tonight is June the 9th, 2017, and I have in a new toy that I want to share with you guys and ladies out there. This is my answer to the portable PC-based audio analysis hardware. I got it in just 2 or 3 days ago. I still have a lot to learn about it. I always spend hours and hours. I'm very slow at learning these things. It comes in, I bought 3 different pieces. I bought this piece, the Analog Discovery 2 mainframe, if you want to call it that. This little board right here adds on and gives you B&C connectors, so you don't have to use these little, what do you call them, fly wires or whatever you call it, that you can plug on here and do the same thing. Comes in this little box here. It shows you what the pinout is for each one. Really quite a nice little device. I wanted to do all this for free, but it just wasn't working. So I decided to spend some money, and it's got some features that I really like. It's got a couple of things, so I'm only going to do 2 things tonight. I tried to make a video earlier on the whole thing, and it just turned into a nightmare. So I'm going to talk about 2 things only. Okay, yeah, also I bought 2 scope probes. These probes come 2 for $20, $10 a piece. They you can use the compensator here, and they work great on my Tektronix scopes over here. So I'm really pleased with those. They have a yellow, let's see, the software has a yellow and a blue display, so I put the yellow and blue there. I use fingernail polish, put a yellow and blue there, just anything to help me keep straight, because I tell you, I can get so mixed up when I'm driving these things on a PC. Once you get it, you just look for the software. It's easy to find, install it, and then you got to learn to live with it. I don't know what else to say. And of course you got to have all the auxiliary equipment, like you know, dummy loads and what have you. All you guys are as advanced as I am in the measurement of audio equipment, so there you go. Oh, and we're going to use this amplifier right here, my pride and joy, my old Williamson stereo amp that uses the Acrosound transformers. I made a 7-part series on that some time back. This is a beautiful performing amp. Pair of 6SN7s driving these, same here. Anyway, let's get with it. Here's what the software looks like. I'll do the best I can to make this as painless as possible. Okay, the only 2 things I want to go over tonight are the scope, right here, and the wave generator. I'm going to start the wave generator. And there it is. It's set right now at 1 kilohertz, 1 volt, no offset, symmetry, perfect. Okay. It has a lot of nice features. You can go sine, square, triangular, all these wave shapes in there. You can go up here from simple to basic, cluster. You can do sweep. It's really pretty darn nice. See, if I click on sweep, and like right now I'm sweeping from 1 kilohertz to 10 kilohertz, or I can say from 20 hertz to you know, 20 kilohertz, and it works. It's got a dampening thing here, which I take off. I don't damp it, so it's always the same amplitude. We're not going to do any of that, but there's a lot to learn about it. Okay. So we want to sine, and we want to get rid of all this stuff. We don't want sweep. We just want simple. Okay. We're going to raise the voltage up here to 5 volts. Now, what they mean by 5 volts is they're talking about 5 volts peak. Peak is from 0 to right here, which you multiply times 1 over the square root of 2, which is about 0.707, to get RMS, which will be 3.53 volts. And it does exactly 3.53 volts from well below 20 hertz. I can't measure anything lower than 10, up to over 100 kilohertz. So it's just, it covers the audio range just really well, like a lab instrument almost. Or, yeah, it really does. It does an excellent job. Okay, let's hit run. Now the first thing you have to do, actually, and you can do it with this, is you would set the generator over there to a square, and then you would hook your a probe up to its output of the square wave, and then you would adjust the compensation right here through this little capacitor there. I've already done all that, but I'm just kind of mentioning it. They give you the little tool to make sure that it's nice and square. So you want to set that up before you start really trying to make measurements, or everything will be goofy. Okay, I hope I can make this go well. Now, the first thing I'm going to do though, and I need to set this down and take this off. I'm just going to put this, I'm going to take off the dummy load, because we're not going to measure the amplifier right now. We're going to evaluate this guy with this equipment. Frequency, THD, voltage output, everything. Well, there it is, 3.53 volts at 1 kilohertz, which is exactly the RMS voltage. As I just mentioned, it's 5 volts peak, or 10 volts peak to peak. And that's at, that was at a kilohertz. Let's change this guy right here down, say to 20 hertz. There it is, 3.53 volts, 20 hertz, 0.06% THD at 20. We just saw 1,000. Let's go to 20,000. 20 kilohertz, 5 volts, 0.353. I mean, it's as flat as a beam of light. 20 kilohertz, THD of 0.0117. So the signal generator in it is excellent. 0.01% or below is, in my opinion, plenty good enough. Okay, now let's look at its oscilloscope. What we're looking at over here with this one is, this is what it looks like. Here's what it looks like on a high-end scope. Okay, I'm going to turn the lights on and off. So it's got a beautiful display. There it is. I mean, we can change the vertical and the horizontal, however we want. I believe if we just rolled, no, I'm sorry. We've got to go over here to Windows. We've got to open up another one. We're going to open up Scope now, and there's our scope. And we've got to hit Run right here. Run. Okay, there it is. And if you roll the mouse, see, it starts opening up. Okay, we're looking at both channels now. We're looking at the yellow channel. That's why I put the yellow thing on it, and the blue one. So if we want to take it off, we just go up here to the blue where it says C2 and right click on it, so the blue goes away. Let's go over here and change our range to 200 millivolts per division. So it'll open up. There it is. I know there's an awful lot of glare. I'm sorry, I just don't know what to do about it. Even I don't see any glare on this PC except when I'm except when I got the camera on it. Anyway, it looks really good. See, nice and sharp. There's my mouse. Okay. I'm using a 10-to-1 probe. So see, it says it's 0.5. See, there's the 0.4, 0.5. But it's really 5 because it's a 10-to-1. All of that's right. The frequency and the amplitude of the signal generator and what the oscilloscope shows is really very good. I'm actually quite impressed with it. What did I want to show you? Okay, well, let's just take it straight off of here, and I've got to set this back down and put this connector back on it so we can plug it into the amplifier right here. We'll turn it all the way down. Now we're going to hook our dummy load back up. I want you to see how it actually displays signals once they get distorted. How it actually looks. Let's see. Now, I've got this thing right here set up. The way you set this thing up is you go Shift, Input, Power. So I've got it set up for 8 ohms. You can change all that to whatever you want. 8 ohms. And I hit Store, and then you go here to decibels, or there's power, PO, right there. So we're going to be measuring power across 8 ohms. Okay, I'm going to be doing the volume right here, and we're going to be driving it from here. Okay, let's see what we get. We drive it up to, I don't know, what about 20 watts. Here's what it looks like on the real scope. Here's what it looks like over here. Of course, we got to change this to, say, a volt per division. There it is. Nice and sharp. That's at 20 kilohertz too. By the way, see, 20 kilohertz. The THD on the amplifier is 0.7, about 0.8. Right at 20 watts. Beautiful performing amplifier. I just can't brag on that thing enough for an old Williamson design. There's what it looks like on another scope. Okay, now, you know, looking at a perfect sine wave is kind of boring. So let's drive it up into some distortion. I'm going to drive it up until there it starts to clip. Okay, actually that's pretty good. See how it's all wrinkly at 20 kilohertz? You can see the anomalies all over it. Now this is a really good example. I won't have to see, it's got a little slant right there. Look over here at another scope. Looks just like it. I know this scope is, let me turn down the brightness on it. Yeah, you probably see it better when it's not so bright. But you can see the same thing. Meaning that, you know, the wave shape is accurate. See, it's got some wrinkles right here coming up, got some wrinkles right there going down. Same thing there. So it's true. It's linear. And it does it at 20 hertz. It does it at 20 kilohertz. It does it way up above that. Let's go back to our generator, and just to prove it, let's go to down here to 20 hertz. Let's go back to our scope. Oh my goodness. Well, we're at 20 hertz, and there's our 20 hertz, and we're overdriving it. Now that's good, actually. Now I've got to roll this thing way back. Oh, there it comes. Yeah, you can see it coming into focus. Okay, there's our 20 hertz. Like I say, distorted on purpose. Square, you know, slanted. You can see a little notch distortion right there. See it over here. It's a little bit different shape, a little bit. Not too bad though. This one's a little sharper, and the notch distortion is a little higher up. Let's see if we can get this one to sync up. It's actually hard to get the output of that thing to sync up. Yeah, that's not going to work. Sorry. I wanted to show you on the second scope. I'd have to take it off. That's at 26 watts and 7% distortion at 20 hertz. But it's actually pretty good. Yeah, that one's a little bit different from a high-end scope. Well, actually, let's see what this one looks like. I think we'll be able to sync on it now. Crying out loud. Boy, that's bright enough, isn't it? Let's see if we can turn that down just a little bit. Okay. There we go. Okay. There we go. So that one, see how it's slanted? It's got more of a slant to it. It's got a little glitch down here. This is a 350 megahertz scope. And I think we'll see the same thing down here on this 350 megahertz scope. Got that same sharp slant with a glitch down here. This one is a little different. It's still good. You see, but it's good. It's good. That's just at 20 hertz. So the scope and the signal generator are quite nice. I've got no complaints. This thing will do a really nice job for the audio enthusiast that wants a portable PC-based signal generator and oscilloscope. And it's got a lot of other features I'm not going to get into tonight. Let's see, if we go to workplace, new, no, cancel. Oh my, that's a heck of a time. Waveforms, yeah. See, it's got scope, wave generator, power supplies, voltmeter. We'll get into all of those later, and a spectrum analyzer down here at the bottom. We'll do the voltmeter and the spectrum analyzer on another video. But there it is, window, wave generator, and our scope. Let's crank it down where it's not so distorted. Oh yeah, we got to hit run again. That should actually go to 0. There it is. I'm going to turn it all the way down. Oh yeah, well, we got to go back over here to wave generator and tell it to run again too. Then go back over to our scope and crank it up too high again. There it is. So, very nice little piece of hardware. It's not free. This piece, and the scopes are all 3 different items. And it was all about $327, I believe. I ordered it from Mouser. So there's the Analog 2 Discovery. Excellent signal generator. Does sweep. Does 2 channels. It goes well up into the megahertz range. I think they claim it goes to 30 megahertz. It does not, in my opinion. Let me do one more thing since this one is turning out better. I've tried this several times tonight and I think it's just been beating me up really bad. Simple. Let's go to sweep. And okay, we should be sweeping right now, I believe. No, we're not. We're going to sweep from 20 hertz to 20 kilohertz in 1 millisecond. Okay, we don't want to do it in 1 millisecond. We want to do it in 5 seconds. Let's see what we're seeing here. There it is. See, it's sweeping. Okay. But you don't need to see it on this scope. You need to see it on this scope. Okay, we've got to raise, because we're driving it a whole lot less. Let's see. There it is. It has a little trouble with the sync, but hell, don't they all? Well, this one's got a little bit better sync on it. But you know, this thing was built in the late 70s, early 80s, and this thing back when it was new in those days was $8,000. But nowadays we can have this. You know, I've got to digress here just 1 minute though. I love vacuum tubes and electronics. It's a passion I can't get enough of. But nowadays, this little guy right here, this little guy practically replaces this. You know what I mean? Kind of heartbreaking, isn't it? It's almost like this little RTLSDR, this thing just darn near replaces my magnificent Collins R390. I mean, not really, but almost. Yeah, this is a little RTLSDR. Hey, well, such is progress. But anyhow, I know you guys and I, we love this vacuum tube stuff. We love instruments. We love to make these measurements. And there you go. For a little portable audio analysis platform, I think it's pretty cool. Oh, my many thanks to Tom. Here's his Tom Tech Test. I want you to check him out. Check out his videos. He's made a number of videos on the Analog Discovery and the Analog Discovery 2. He compared the two. He just made a lot of measurements. He's got a beautiful lab of equipment.
So check him out, and your comments are always welcome. I always enjoy the discussions we have, and I'm sure I'm going to learn a lot about this. And then I'll show some other features another night. Thanks for watching. Stay safe. Have fun.